Okay, so welcome back. Now I encourage you, if you like this video, please hit the like button and hit the subscribe and the bell icon and everything else. And if you like it, please share with your friends. Honestly, I get maybe 50 views in a couple months from my videos, and if people aren't really interested, it makes me much less likely to continue this. So I encourage you, share it with your friends if you like it, and let people know. It would help me out and give me more reason, encourage me to do more of these. In this video, we're going to talk about how to develop what's called a subnet scanner application. Let me run this to show you what we're talking about. So here, I'm doing it in C#, a simple WinForms application. And this is the application. You can see it's fairly simple. Windows Forms with a big text, multi-line text box, and it's got two buttons. One is a scan button, one's an exit button. So what I'm going to do is I'm going to hit the scan button, and you can see it's off doing some work, and I can move the window, which is a nice thing. And what it's doing is it's scanning my network, and it's telling me I have 3 computers online on my network. And it found 3, and it took 4.7 seconds to find those 3 computers on my network. So that's basically what the subnet scanner does. It is scanning the IP addresses on my network. And if you're on a home network, you've probably got an IP address for each of your devices that looks something like 192.168.0. something. And that something can range from 1 to 255. So on your network, there's 255 possible IP addresses that your computers can use. The task of this application is to do what's called a ping for each of those 255 IP addresses. And the ping basically sends a message to those IP addresses, and if there's a computer there, it will respond to say, yes, I'm here, and here's my information. Again, this is going to send 255 pings to see who's there. Now, you can do a ping. You can go down to your command prompt, your command window, and type PING space with an IP address like 192.168.0.2 and do that command, and if there is a computer at that address, it will come back and respond to you. So that's all we're doing. We're doing a basic ping command for each of those IP addresses. So now there are some challenges we need to address in this application. And for example, if we were to one by one send a ping for each IP address in sequence or in series, or what's called synchronously, you do one, you wait for an answer. Then you do the next one, you wait for an answer. If we were to do that, this can take like 5 or 10 minutes to get through all 255. So that's one of our challenges. We don't want to wait 5 or 10 minutes. We want it to be done, like in this case, it's done in 4.7 seconds, all 255 pings. So we're going to have to come up with a way to do this, what's called asynchronously or in parallel, so that we can do hopefully all 255 simultaneously and get an answer real quick. Okay, so we're going to look at what's called async and await and tasks, and we're going to figure out how to do this very quickly. We're also going to be looking at events because, as you can see here, when I get done with all 255, I need to notify the application, okay, all 255 are done, so update this text box with the summary information. I found 3 devices, and it took 4.7 seconds total. So we're going to have to generate an event and handle an event when everything's done. Now, to give an idea about how we're going to do this, I want to go through an analogy that might help. Now, let's assume that we have a factory, a big empty factory, and there are 255 workers. And each of those workers are going to be given a task, all right? And that task will be, each of the workers has associated with them a tool cabinet. Let's say it's 50 feet away or something. And the task that we're going to give to each of the workers is we want you to run to your tool cabinet, open up the cabinet, and find out if there's a wrench. And make a note if there's a wrench or not. And then come back to where you started from. And if you found a wrench, there's a big buzzer you need to hit. There's a single buzzer for all 255 workers. And when you hit that buzzer, it will increment a big LCD sign on the wall that says, one more wrench was found. And when everybody's done, it will have a number that indicates how many total wrenches out of the 255 have been found. Now, we also need to know for each of them when they're done, right? When they're back at their starting point, because we need to keep track, because when they're all done, then we can get the summary of, when we know what's the final answer. But we have to know when everybody's done. There could be some slow people that, are taking a lot of time. So we need to know when everybody has checked in back at the starting point. So we're going to have to keep track of when they're done, right? So they're going to have another buzzer, which for each worker that says, when you press the button, that means that's telling us that I'm done with my task, all right? So we're going to have 255 workers, each with a task. So there's going to be 255 tasks. And that task is to run to your particular cabinet. And there's 255 different cabinets. Run to your cabinet, check for a wrench, and when you come back, let us know that either you're done or you found a wrench, and so we can put together a summary. And that's basically what we're doing here. So that we don't have to do this in series or synchronously, we want to have 255 workers, ideally, that can go do it all simultaneously. And at the end, like we show here, 3 workers found a wrench and they pressed the button, and we got the data from them on who the worker was and where the wrench was. And then when we know that everybody's done, when all 255 have checked in, then we can put the summary information, okay? So again, we need to approach this with a view to a parallel processing where we do multiple or 255 events in parallel simultaneously, all right? So we're going to have to figure that out. The way we're going to do that is called async or asynchronous operations or asynchronous tasks, which is tasks in parallel, and await. So there is in Windows Forms, this is going to be a Windows Forms application, we're going to use async and await and a list of tasks to perform what we just described. Okay, so now that we've got an overview of what we're trying to accomplish here, let's take a look at the code that we're going to use to implement it. Now, there's a bunch of ways you can do this. So I've basically got 3 major components to this application. Here's my main Forms 1. Again, this is C# Windows Forms application. And I've got my main Form 1, and it's fairly compact. I don't like to put a lot of stuff in my Windows Forms. I like to offload that to other places. And you can see I've got basically I'm instantiating a class, and we'll talk about that. This is the class that does the actual pinging of each of the IP addresses, and we'll talk about that in a bit. My Form 1 has the standard initialized component that comes with every new Windows Forms application. Here I am just setting the font color of the text box to red. You don't need to do that. Here I am subscribing to an event that's going to be generated by our pinger. And basically we need that. Recall when we run this scan, we need to be notified in our main application when it is done with all the pings of the 255 IP addresses, it needs to be notified of that event so that it can then put this summary in the text box, okay? So that right there, that line is subscribing our event handler, which is shown right below here, the net ping event, subscribing to that event that's generated by the pinger. All right, we'll talk about that. But you can see all it does is it goes down here to the event handler for that ping event that says we're all done with all the pings. And all it does is it calls another method right below here, which is print results. And it prints that results of the of all the pings, okay? So it prints for each of the devices it found, it prints the name and the IP address. It basically, we're keeping a list of the hosts or the devices we found, and it's basically just printing those out. In our case, we had 3, printing those out with the name and the IP address, and then it is finding the total time down here, the time span in seconds, so we can print it out, and that's about all it does. So it's pretty straightforward. We'll go into a little bit more detail on that later, but you can see the main application is really very compact, okay? We just have a subscribe to a ping event when all the 255 are done, and that just prints the results. And the only other 2 we have here are the event handlers. So as you recall, we've got 2 buttons. We've got the scan button and the exit button. So we've got down here the event handlers for those 2. And you can imagine for the exit button, it just does an application exit, nothing fancy. And for the scan, that is going to initiate the pings of all 255 IP addresses. And all that does is it appends the text box with a note that says, I am scanning the base IP, which is the 192.168. It basically prints out this. Scanning 192.168.0, which is the base IP address, which is stored in this net pinger class we'll talk about. And then it runs a method that actually goes through and does the pinging. This net ping.runping.runpingsweep.async does the pinging, okay? So really nothing fancy here. We've got 2 other classes here. And again, we briefly talked about the net pinger, and this is the class that does the actual pings. It sets everything up and does the 255 pings and does them asynchronously or in parallel. All right, and we'll go into detail. And the last class I have is called a host data class. And that's a very simple class. All it does is hold the data. When this pinger pings an address and finds an active computer there, is instantiated a host data object, and it just stores the name and IP address of each successfully found device on the network. So it's got a host name and a host IP address. And that's about it. The string array is just used to parse the data received from the ping command into a host name, okay? When we do a ping, it responds with what's called an IP host entry, and that has the data. It encapsulates all the data for the host that was found, and we have to go parse some of that to get the actual name of the host, right? Like supercomputer and HP Envy. So it just does a string.split to remove the name from the string you get for the host name, and we grab the 0th element, which is the first element, which gives us just the name, not the long host name. Okay, so really fairly simple. You're just storing two bits of information about the successfully found host, and to get one of those, it needs to do a little parsing. Okay, so really not much. The real worker here is this net pinger class. All right, and as we said here in the main forms, I just instantiate a netpinger object called netping. So let's look at this netpinger, and you can see it's using quite a bit of system libraries. So we're doing usings for system collections.generic. That's so we can make a list of tasks. Again, we've got 255 workers. We're going to give each one as a task, and that task is to check the specific IP address that they're assigned to. So we're going to have a list of 255 tasks. We're going to need collections.generic, and then system.threading, since we're going to be doing some asynchronous processing or parallel processing with multiple threads. We're going to need that. System diagnostics. We're going to get the stopwatch, the timer, to figure out how long this whole thing takes from system diagnostics. And then system.net and network information. If we're going to do IP pinging, we're going to need those. Okay, so those are the using statements we're going to need. And when you go into this pinger class, it's basically got two major components. Here I'm doing I've got a region that's just, I'm initializing stuff. Okay, so you can see like I'm initializing the base IP address as 192.168.0 dot something, and we're going to add to that the start IP and the stop IP. So if we're going to step through 255 IP addresses, we're going to take this base string of an IP address and concatenate 1, 2, 3, 4, up to 255 to get the 255 IP addresses. And then we're going to have a string IP which has the total concatenated IP address for each task. And then timeout is something, when we do a ping, we can specify a timeout. And that just says, hey, if it gets to be too long, we're going to note that. Number found, that's going to keep track of how many successfully found devices. In our case, we found 3. So we're just going to keep track. And then lock object, we're going to talk about in a bit. And here we've got the stopwatch. We're instantiating a new stopwatch. And then a time span that's going to keep track of how long this whole thing takes. And then we are defining an event handler, which is going to return a string that we probably won't use. But it's a public event handler, and it's called the ping event. And again, this will be generated. This event will be generated when we finish going through all 255 IP addresses. We'll generate that event, and our main application is subscribing to it, and it will just do the ping event and print results, and we're done. Okay. So we also have we have defined a host, IP host entry for a host, which we'll see. That's basically what gets returned when you do a ping. If you successfully find a host, it's defined as this. And we're also going to keep a list of those. We're going to keep a list of hosts so that we can have that for later on to do our summary. And we'll talk about that, but that's basically all we're doing. We're initializing here. And then we're doing 2 ping methods. And again, when we do a scan, it tells you we're scanning, and then it actually calls one of these ping methods, which is run ping sweep async. Okay, so it goes into this net ping device, the object that we instantiated, and runs this. So this is what it runs, this one right here. And you can see it's called async. All right. And down here we have an await. And we do this so that we can run these things in parallel. So let's look at what this thing does. Now this method doesn't actually do the ping. It configures everything so that it can call this next method, the second method, ping and update async, and this actually does the pinging. So this just basically prepares everything and then calls this other method to do the pinging. So let's take a look. Here I mentioned we're going to have 255 tasks. This basically initiates a list of tasks. so that we can start adding for each of the 255 IP addresses. We add each task to this list. So we'll have a list of all the tasks. Here I'm just starting the stopwatch. I'm doing a restart. So if we click the scan button again after it's done, it will start back at 0. Otherwise, it will just increment the start time or the time span. And then the number of found is starting out at 0. And in our case, we're going to increment it until 3. So here, all I'm doing, this for loop, I'm starting from, again, we saw the start IP address is 1 and the stop is 255. And here all we're doing is we're taking the base IP, which is 192.168.0, and concatenating this 1 to 255 as the address. Okay? So this is developing 255 IP addresses that we are going to use to make the 255 pings. So starting out at 1, we've got IP address. This will be 192.168.0.1. We're instantiating a new ping object, what's called a ping object, and this is what we will refer to do the actual ping. Okay, so we've got our 192.168.0.1. We've got our first ping object, and then we are defining a task that is calling this second method that actually does the ping. And we're feeding it the ping object and the IP address, 0.1, okay? So we're all set. We just need to call this to do the ping, and then we're adding that task to our list of tasks, okay? So here we're going through 255 times to generate 255 tasks with 255 ping objects and 255 IP addresses, okay? So now we've developed these 255 tasks, and then what we're going to do is this await, okay? And this checks to see when all of these tasks have been completed. We've done the 255 pings. What we do is we use this continue with, and what it does, it stops the stopwatch. So all of the tasks are completed, stop the stopwatch, and figure out how much time it's taken. When this is all done, we've got this ping event that we define. So what this says is if there are subscribers to the ping event, like we've got our form 1, we've subscribed to the ping event, netping.ping event. If there are subscribers, which there are, then we will invoke this event, and we will pass it this time, elapsed time, to string, okay? So this actually invokes the event and calls this event handler, which does the print results. So that's basically this. And here is the event that gets called ping and update async. Here's the method that gets called. And all it does is really, this is the main worker of this whole thing. This actually does the ping, okay? So you're feeding it the ping object and the IP address, and it takes that ping object and does a send ping async to this IP address that you fed in, right? So this does the actual ping. And we are awaiting this. So it means that the thread that is running when this gets called can go off and do other things while we do this ping for this particular IP address. And remember, this is going to get called 255 times, this ping and update async, with 255 different pings, objects, and 255 IPs. So it's going to do this. And the real important thing here is this configure await, and you feed it a false. And the reason why is because, for example, if I start this up and I do a scan, I can move this window around because of this configure await false. All right. What this does is it says, okay, I'm going to send the ping and wait for the response, but while I'm waiting, my user interface thread can go off and do other things, and I'm going to allow other threads, the available threads, to go finish this work. Okay, so this is very important. This configure await false says don't have the UI thread do all this work. Have another available thread to do this additional work. Okay, so that helps us to have a usable UI while all this work is being done. Okay, so what this send ping async does is it provides a reply that tells you, was it successful ping? Is there a device there or not? Okay, if the reply.status says IP status equals success, which means yes, I found a device at that IP address, then what we can do is we can grab the host data using this dns.getHostEntry for this particular IP address that we're working on, and that is our host. That is the host data. Now we can take that host data and add that to our list of hosts. Remember, we had a list of hosts. We're adding a new host data object at that IP address to our list of hosts. Okay, so now we've got an additional host. In our case, we're going to have 3 total. And then down here, we are doing a lock object for the number found. Now remember, in our analogy, we said there's going to be one big buzzer. And if a worker found a wrench in the cabinet, they're going to hit that buzzer. Now you can imagine if there are 255 workers, there might be a couple workers simultaneously get back to the buzzer to hit it. And you can't have that, because if 2 people hit the buzzer at the same time, it's not going to recognize 2 individual wrenches found. It's going to count that as one hit. So what this does is that this lock object basically locks the number of found increment so that only one can do it at a time. All right, so one positive response at a time, and you have to let that do its thing, and then the others have to wait. So this is important to make sure you get an accurate count of the number of found wrenches or the number of found hosts. Okay, so again, this is what does the work, and it does it asynchronously, and it allows a lot of threads to go through and do this. Now, I do want to mention again one thing I mentioned before, and that is regarding this when you actually do the ping for each of the 255 IP addresses. This had me scratching my head for a good half a weekend, and I finally found the answer. This was from a YouTube video from the NDC, I guess National Developers Conferences, and it was correcting common async await mistakes in .NET, and it was from July 2019. And I had been going along without this configure await. Okay, and I had been running, everything is working fine, everything's running in parallel, it's running really fast, but my problem was I couldn't move this UI when I did a scan. So for example, I'm scanning and I can't move the UI. I'm clicking and it doesn't move. So when it gets done with the scan, it will allow me to move it. See, it's okay now. So in that video, I found that if you add this simple configure await false, then you can access the UI while it's doing its scan. So very helpful. And I encourage you to take a look at that video. There's some really good tips on using async and await. So anyway, I think that's about it for this video. If you want to copy any of it in detail, just hit the pause button on your video and copy away. Anyway, I hope this helps. Take care and have a really good day. Thanks.